On June 30th, 1908, something struck Siberia with the force of 1,000 atomic bombs and left no crater behind. What happened that morning remains one of history's most perplexing catastrophes. A remote region of Russia, untouched and barely explored, was leveled in an instant. 80 million trees flattened like matchsticks across an area the size of a small country. Yet when scientists finally arrived years later to investigate, they found something that defied every expectation. No impact crater, no obvious scar in the earth, just devastation. And a mystery that's haunted researchers for over a century. The region is called Tunguska, a remote corner of central Siberia, so isolated that indigenous Evenki herders were among the few who witnessed what occurred. On that June morning, witnesses reported a brilliant flash of light streaking across the sky, brighter than the sun. A sound followed, a deafening boom that traveled hundreds of kilometers, knocking people to the ground despite the distance. In the years that followed, the story faded into obscurity. The Russian Revolution consumed the nation's attention. Siberia was remote, lawless, and largely forgotten by the outside world. It wasn't until 1927, nearly 2 decades later, that a scientific expedition finally reached the site. What they discovered there would reshape how we understand planetary catastrophes. The lead scientist was Leonid Kulik, a Russian mineralogist determined to find meteorite fragments. He expected to locate a massive impact crater, perhaps surrounded by meteorite debris. Instead, he found something far more unsettling, a forest completely annihilated, yet oddly arranged. The trees weren't scattered randomly. They radiated outward from a central point, as if the blast had come from above, pressing downward with immense force. The explosion released energy estimated between 10 and 15 megatons, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. Yet there was no crater, no massive hole in the ground. This discrepancy would fuel decades of speculation and competing theories about what actually struck Siberia that morning. The leading explanation, accepted by most scientists today, is that a meteor or comet exploded in the atmosphere before impact. Rather than striking the ground as a solid object, it detonated miles above the forest, releasing its energy downward in a catastrophic shockwave. This would explain the radial tree pattern. It would explain the absence of a crater. It would explain the sheer magnitude of destruction. But alternative theories persisted for decades. Some scientists hypothesized an antimatter collision. Others suggested a black hole. Fringe theories proposed extraterrestrial intervention, that advanced beings had deliberately detonated something over Siberia. None of these held up to scrutiny, yet they reveal how profoundly the event confounded conventional understanding. The real puzzle isn't what hit Siberia, it's that we came so close to never knowing. The explosion occurred over one of Earth's least populated regions. Had it struck a major city, millions would have died. Had it impacted just hours earlier or later, the rotation of the planet would have placed it over a densely populated area. London, Moscow, New York. The margin between cosmic indifference and human catastrophe is terrifyingly thin. Scientists now understand that impacts like Tunguska occur roughly once every 1,000 years. We've been fortunate, but our luck isn't permanent. NASA and other space agencies now track potentially hazardous asteroids, attempting to map the threats we can't see coming. Tunguska taught us that the sky isn't simply a source of wonder, it's also a source of danger. The Evenki people who survived the blast carried stories of it for generations. They called the blast site the place where the forest was knocked down. For them, it was a spiritual event, a reminder that forces beyond human comprehension existed in the world. Science would eventually offer a rational explanation, but it couldn't entirely dispel the sense of awe and unease that the event inspired. Today, the Tunguska region remains largely undisturbed. The forest has regrown, but the memory lingers in scientific literature and historical records. Expeditions continue to visit, searching for meteorite fragments and studying the recovery of the ecosystem. Each discovery adds another layer to our understanding of what occurred that June morning over a century ago. But the fundamental question remains, how well do we understand the threats that exist beyond our atmosphere? Tunguska reminds us that certainty is a luxury we can't always afford. We study the skies, We catalog the risks, yet the universe operates on scales and timelines that dwarf human comprehension. What we call mystery, the cosmos calls routine. The investigators who first studied Tunguska were working with limited technology and fragmentary evidence. They couldn't explain the absence of a crater. They couldn't definitively identify the impactor, yet they gathered enough data to construct a plausible narrative. Modern science has refined that narrative, but the core mystery, what exactly happened in those final moments before impact, remains elusive. Some researchers have proposed that if a more detailed examination of the impact zone could be conducted, additional meteorite fragments might still be recovered from the permafrost. These fragments could potentially resolve remaining uncertainties about the composition of the impactor. But Siberia's harsh climate and remote location make such expeditions extraordinarily difficult and expensive. What's undeniable is that Tunguska changed how science approaches planetary defense. It demonstrated that Earth is not isolated from cosmic hazards. It proved that impacts capable of regional devastation occur with regularity in geological terms. And it revealed that our species exists in a precarious equilibrium with forces we can study but not control. The explosion flattened 80 million trees across 150 square kilometers. Had it struck just hours earlier, the rotation of Earth would have positioned a major population center directly beneath the impact zone. Instead, it struck empty forest. Luck, timing, cosmic indifference. Call it what you will, the result is that humanity survived to investigate its own near extinction. The Tunguska event remains unsolved in the sense that mysteries always persist at the edges of knowledge. We have a compelling explanation for what occurred. We understand the physics. We've mapped the damage. Yet the event retains an almost supernatural quality, a reminder that our understanding of the universe, however advanced, rests on foundations far more fragile than we'd like to admit. Every night, countless objects streak through our atmosphere. Most burn up harmlessly, creating brief flashes we call shooting stars. But some are larger, some are dangerous, and some, like the object that struck Tunguska, carry the potential to reshape civilization. We monitor the skies now, we prepare, we study history, but we know the truth. The next Tunguska is coming. The only question is when and whether we'll be ready. Subscribe. Each week, we investigate cases where the official explanation doesn't quite fit, and the real story remains hidden in plain sight.